All right, welcome back. We are COMP2142, Game Artificial Intelligence 1 in the winter 2026 semester at Georgian, and it's week 6, part 2 of our broadcast and recording. And in the previous part, we talked about some data structures again. So search algorithms, a little bit about recursion, what that is, we didn't actually do it, and hashing. We talked about that, and specifically maps. So we talked about maps and what they are, how to use them. And now what I want to get to is our assignment 1. Okay, so I want to get to this. So I'm using a project that is that we use, for the first part. I'm just going to get rid of all this. This is just my testing for the sorting and searching algorithms. Compile and save. And I don't need this one anymore. But what I want to do is test to see what we have so far. So if I run the code right now, the way it works is if I go and seek, then I can seek towards the goal. It'll do that, no problem, right? If I stop it and click arrive, it'll arrive, but it will stop one short unless you increase the speed to 200. I haven't changed that. That is for you to change. There it is. And then it spins around. So this is something we have to fix. We're going to fix this in the second half of the semester, because this is part of your assignment. So I don't want to give you the whole solution. You should already have the solution. It's not that difficult to figure out. All right, so that's what we have. We also have, if I restart this thing, so if I go kind of back and restart it, and if I click on debug, then I have these debug whiskers. And this is pretty cool, right? I have these debug whiskers. I can put them wherever I want. However, right now, the way it works is if I have my enemy and the whisker is intersecting with the enemy, let's make it so you can see it a little bit easier, right? You can clearly see that there's no interaction. These are just debug lines. That's what they are. What I want to do now is I want to make it so that these whiskers interact with the enemy. They can tell if there's a connection or some kind of collision, right? So we have to make them traces, line traces, as opposed to just kind of drawing a debug line. So how do we do that? So back to our blueprints. What I want to do is in the grid character, I want to make a new function called obstacle avoidance. Let's go in there. So in the grid character, I'm going to make a new steering behavior function called obstacle avoidance. This is going to be of type steering behaviors. Here it is. And it's going to have a sequence node. Now, to get a sequence node, if you press S and then left click, you'll get the sequence node in there. Okay. And what we want is two parts: the avoidance direction multiplied by my rotation rate. So if I take my get avoidance direction and get rotation rate, then if I do that and I multiply them together, that'll give me the angle, the best angle I can change in the direction that I'm going. So the bigger my rotation rate is, the faster my angular acceleration, the rate of change of how fast I can change my acceleration, right? And what I want to do is I want to be able to, only rotate that much. So example, if my rotation rate is 15 degrees and I know my avoidance direction is negative, I'm going to go 15 degrees to the negative maximum towards where I have to go. I'm not quite where I need to be there because I can't turn on a dime, right? It really depends on my rotation rate. And then I want to make a rotator. So make rotator. So rotator is really a quaternion. That's what it is. And I'm only going to use the Z or the yaw that I'm going to change. There we go. And then from there, I'm going to take the start pawn. So get start pawn. And I want to set the rotation. Set actor rotation. I'll be okay. And I want to set that with this new rotator, whatever that thing is. So all I'm doing is I'm changing the rotation of the start pawn to this. And then we're just going to put that together. and this is the first part. So the first part is really compute the desired rotation of this step, and then rotate the ship. That's what this part is, okay? Part 2 is where I want to return the start pawn's new forward vector, because once I've rotated, I have a new forward vector that I want to use, right? So I want to get the start pawn again, and I want to use the root component, get root component. Now I use the root component because that gives me the forward vector from the root, whatever the root is, right? And then I want to get the forward vector, get forward vector, and I want to normalize this. Normalize. Okay, so that gives me the unit vector, and I want to return that out. So I want to add a return node, and I want to return this out, and this will be the new direction, whatever that new direction is going to be. Okay, so let me explain this one more time. All this, the obstacle avoidance steering behavior does is it takes the avoidance direction, positive or negative, right, and then rotates in that direction. If it's a positive rotation, so the sign is positive, it's going to rotate towards the right. If the sign is negative, it's going to rotate towards the left, right? That's what it's going to do. Okay, so that's it for obstacle avoidance. The obstacle avoidance, behavior. Next, what I want to do is I want to fix this debug line trace. It's not really great right now. So I'm going to open up configure whisker, and that's inside of the start pawn. Here it is. So I want to go to my configure whisker function. Here it is. My configure whisker function only does this. It just shows a trace line if the debug is checked, but it doesn't really do anything. So this part right here we can leave alone, but this part is where we have to change. This has to change right here. So line trace by channel, right, is what's happening here. This is kind of showing a trace line right now, but what we want to do is we want to fix it a little bit. Okay, so we already have this piece, so this kind of does change to see if we have the enemy and all this kind of stuff. This is all in place. This is what this is. So this is already here. Okay, but we're going to reorganize things. So we're just going to uncheck these, and I want to take this part and I want to move this whole thing down here. I want to take this part, move this part up here. Just reorganize when this is happening. So instead of me doing a branch just to show the whisker, which is this is kind of useless for us. I want to show the whisker, but I also want to be able to do a couple of different things here. So let's take a look. So first thing we're going to do is we're going to make a new local variable of type eDrawDebug trace, and it's going to be called draw debug, right? So let's do that. Local variable, call this draw debug, and it's going to be of type eDrawDebug trace. It's a built-in one. There it is, eDrawDebug trace. Okay, it's a local variable. Then I'm just going to stop this for now, this draw debug line. I don't want that, right? What I want to do instead is I want to call or set the draw debug. So I want to take draw debug, I want to set it if it's true, and it's going to be set for 1 frame. And if it's false, draw debug, we're not going to set it at all. That's how it's going to be done. This is kind of fixing this issue, right, where we're going to show it or not show it depending if debug is turned on or off. Okay, so instead of me making a separate debug draw line, I'm not going to do that because our trace channel does it for us. This thing right here, this thing. So our draw debug type, instead of me having to decide one of these, it's going to be based on if the debug is on or off, right? And so I'm going to just drag it in here. That's what I'm going to do. I'm still going to use the trace visibility here, right? And what it's going to do is the trace color it's going to change depending on whether or not I'm connecting with the thing that I'm looking at right now. So if I was to just to make that little change right here, and it's going to look like this at the end. So nothing's changed here. I'm just showing you that this is just what it does. So nothing has changed on this side. This is exactly the same thing. You can see that this is the exact same thing here, just like it was, right? This is instead of, by the way, instead of 1, I made this -1. This is the only change I made because this is the one part that is different. So the avoidance direction is -1 instead of 1, okay? Because this before was 1, and I made it to -1. I found that this is a bit of a bug, so I'm just going to make this a little smaller. But the rest of it is identical. There's nothing different from here to here, okay? Nothing different at all. So compile and save. So now what I want to do is test it. So let's run this thing a little bit. And it's not doing the steering behavior yet, but what I want to do is I want to turn it on. So can I see it? Yes, I can. And now notice that when I put in my obstacle, then it's green. The areas, the whiskers that are colliding with the obstacle now are green. Where they're colliding, like this, you can see that those whiskers are all colliding. Okay, like so. And the other whiskers are red because they're not colliding. Okay, so now we've tested to see if this works. This should work the same thing for you. This is great. Let's put this up on DevOps. So I'm going to say file save all. And I'm going to say git add dot, git commit -m, and we'll say fixed line trace for whiskers. Because before it wasn't really responding. It wasn't doing it. It wasn't telling us. It couldn't show us what was going on. Now it's going to show it to us. Okay, next. Now that we know that this works, the next part is going to be adjusting move to target. So move to target right now, if we look at our code, and again, if I was to look at the grid character and the steering behavior functions, just move to target. Move to target just does this. It basically says two things. It gets the current location of the object that I'm moving and the current direction, right, wherever I'm going, and then it rotates towards that direction. So if I'm looking in one place, I want to look towards the other one, it rotates there. If I'm using a rival, then what it'll do is it'll slow me down. If it doesn't use a rival, it'll just spit out the regular desired velocity. It will just keep going forward. So if I'm not using a rival, okay? And then every frame, it resets the pawn's location step by step along the game board, because that's what we're using right now, okay? And this is okay, this is fine, but we don't want to do just this. We also want to do a check to see if the avoidance direction is not equal to 0. So if I'm not going straight, okay? So we're going to add another thing in here, another branch, right? And this check that we're going to make is basically going to check to see if my avoidance direction, so get avoidance direction, if it's not equal to 0, so that means I'm turning left or right. If it's +1, I'm turning to the right. If it's -1, I'm turning to the left. If it's 0, I'm not turning at all. And if I'm not turning at all, then, well, I can do different things. So let's uncheck this for now. So if it's not equal to 0, then I want to avoid, right? That's what I want to do. If it's equal to 0, if this fails, then I want to do this. I want to just do what I'm regularly doing. So I'm actually changing this around. So this case here, where I'm steering towards the goal, is only when I'm not avoiding something. Okay, that's what's happening. So that's what's going on there. Now, but I want to don't just check the avoidance direction. I also want to check to see that the obstacle is detected. Because if there's no obstacle detected, you know, as an example, then those two cases are important. So get obstacle detected. Is the obstacle been detected? Like, am I colliding with something with my whiskers, right? So that's important to understand too, if my obstacle has been detected. So then let's put this an and boolean. There we go. And that's the condition that I want to use to determine if I'm going to, you know, kind of steer away. This is just steering towards the goal. We already have this part. We're not going to change that part. we're going to add this other part up here. And the first thing is, if the obstacle is detected, then we're going to say that by default, now the obstacle is not detected anymore. Every frame we're going to say it's not detected, and then we check to see if it's detected the next frame. You see what I'm saying? So, because if we leave that the obstacle has been detected always, then it's always going to try to steer away, as an example. And we don't want that to happen, because what if there's no obstacle that's detected anymore? There's no obstacle in the way. We want to, steer towards the goal. So obstacle detected. So here's obstacle detected. So we want to set this as false in this case, because now we want to reset it. That's what's happening, right? Next, we're going to perform our obstacle avoidance. So obstacle avoidance, right? Which gives us a new direction. Wherever we're looking at, whatever we steer in the direction that we're to steer away, a number of units based on the rotation rate. So again, if my rotation rate is like 45 degrees, it's going to steer away 45 degrees, one way or the other way, as an example. And it's going to give us this new direction vector, the new, line of incidence, if you will, where we're moving towards the new location. And then I'm going to multiply that by speed. So multiply by speed gets, here's multiply by speed. And what this is going to do is it's going to give me, because remember my new direction is just a unit vector, and we're going to scale my unit vector by whatever the speed is of my ship, right? And then I want to add in the current location. So I'm going to add my current location. So this one. So it's almost like I'm kind of doing this, right? Instead of rotating towards, I'm rotating away, right? Because this is kind of similar, right? And then I want to set the pawn location. So the same thing here. I want to do here. But instead of saying the pawn location how I did it down here with my arrive, I'm going towards, I'm steering away. So there's a lot of ways, I have to be honest with you, there's a lot of optimizations we can make here, okay? Because you can clearly see this in duplication and some of the stuff that we're doing. For example, I could incorporate this in here instead of the way I'm doing it. I could create another thing that says, even the obstacle avoidance, instead of it returning a direction, I could return the new vector, as an example altogether, because I'm not really doing any of this stuff anymore. But I'm not going to do this because in the future we might need to do some modifications of this. So let's avoid the obstacle, which is what this is doing right here. Avoid obstacle. Now, I have to tell you that this is needing some tweaking, and that's your job to tweak it up, to do a little bit of trial and error, manipulation, and to see if you can make some improvements. I've given you 90% of it, 95% actually, with this stuff. Now it's for you to make it better. So let's see how this works. It should work pretty good now. So I'm going to press play, and I'm just going to zoom in. Let's just make it so that you can see it on the screen a little bit more. So here's a very simple case where I have my start and my end, and I have my obstacle in the middle. I'm going to turn on my debugging, and now if I do a seek, then it's going to hit it and do nothing. It doesn't avoid anything at all. All right, how about them apples? Right, it's going right through. So let's get back to this and see what went wrong. Okay. So we detected the obstacle. So here's where my obstacle's been detected. Right, my start pawn detects that there is an avoidance direction, whatever that avoidance direction is going to be. Okay, so that's something that's there, and that's the first part. The first part is, check to see if my whisker angle is not equal to 0. Let's make sure our code is correct, right? Our obstacle avoidance is giving us a new direction, because what's happening is we're taking the avoidance angle and we're rotating, right, the start pawn, That's what's happening. And let's make sure that that's all good. I'm just gonna go and confirm all this stuff. So here is my just gonna go to obstacle avoidance to confirm. So again, when my obstacle avoidance is checked, I'm taking my avoidance direction, multiplying it by my rotation rate, whatever that is, and I'm giving that my new rotation. Here's my start pawn. That's the same thing. And then my start pawn, my root component, I'm getting my forward vector, and I'm normalizing it, and I'm returning that out as a new direction. So this is correct. Okay? Yay. My move to target, I check to see if my avoidance direction is not equal to 0. And my obstacle has been detected. So both of those two things have to be clear. Obstacle detected. So we're going to get back to that. Thank you, Hayden. But this is why I'm checking all this stuff, right? But I appreciate that. I really do. Then my move to target. Here is my branch, my switch on cell state, my whisker angle, my sine, and let's check this out now. Oh, and this is exactly what you said, which is we did all this, but we never actually made my obstacle be detected. So I'll get the grid character. This is the part where I made a change, actually. Wait, I didn't add that in. Here it is. And the grid character, we're going to set the set obstacle detected to true. Okay? And that's going to happen. I'm just going to move this around a little bit. Because for the most part, like I said, it was the same, but there were some minor differences, and this is one of the major differences. Well, it's a difference, it's a minor difference, but still, it's something that we need to do before we move forward. So, just like it says here, when we detect an enemy, the obstacle has been detected. When the obstacle has been detected and the avoidance direction is not 0, then do this, do the avoidance, right? So that's what this is. Compile and save. So minor changes. Now let's try it out. And if I zoom in, I'm just going to put these down here so we can see them a little better as I zoom in. Let's put that there. And if I kind of press this on and click seek, then we should have funky avoidance. And I mean that by funky. Let's try that again. Let's take a look at what it does. It goes doot, 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 right? And let's try it again, but I'm going to reduce the turn rate significantly to like 25. So let's do it again. And then now the turn rate is different, right? And it's interesting to see the effect of this. I'm going to increase my speed to 200 so we can see what this looks like. And then I'm going to put this in here and see what happens. So it kind of moves a little bit. So let's just reduce the turn rate even more. Put that in there. And you can see that didn't turn much, did it? It does avoid, right? But it kind of skims along in a little way, you know. If I increase the turn rate, let's increase the turn rate. So instead of 45, let's go right to like 60 degrees to show you the difference, right? So this is where we do a little bit of, so that's really weird, right? What happened there? So it even collided, right? So what's wrong with this situation? What is it doing? So let's do this. Let's put the obstacle there, and I'll put the thing right there and see what happens. Well, kind of went away. I can decrease the rate, so let's make it so it's only 100 instead of 150 and see what that looks like. 100. There we go. And let's put that there and the obstacle there and then see what happens. Well, it does weird stuff. Look at that. It just flips around and then it stops. So that's weird. Let's move that back to 150. So 150 seems to be the minimum, really, right? It's just our grid, the way it is. But you can see that it kind of flips out there, literally flips out, right, as it goes back. Okay, let's decrease the angle again to something like 30 degrees. And this is where we're tweaking our AI, right? Where we're trying to figure out what the reasonable, values are that we can use if I was going to program AI to move this way, right? As an example, I wanted to avoid, my obstacle. How do I do that? All right. And it's kind of weird what it just did there, but, if I put my obstacle, let's put that over here, and I put my obstacle there. Let's see what happens, like right next to the, there we go. So it did do it, but now when it comes back, it's going to avoid it again. There we go. So that's not bad. It's not terribly good, but it's not bad either. There, it's trying its best. So a couple things, 150, 30-ish. Step delay is just going to allow us to see it better. So if I stop it and change the step delay so it's like bigger, right? And if I click seek, you can see step by step, each step, this is each step right here. Each step, it moves and it makes some decisions. This is where it becomes easier for you to do your troubleshooting. So I recommend you slow it down, right, to see what you're doing there, right? Step, step, step. Every time it's stepping, it's moving. It's calling its the functions that it's calling. Okay, each of those move to target and rotate towards, all those things, it's calling those functions. That's what it's doing as it's rotating around. So now it's detected it, now it moves away. It rotates the rotation rate, and the rotation rate being 30 degrees. Okay? So if I lower the rotation rate more than this, let's say I lower it to something like 15, right? Now let's see what happens. So now it takes longer, that's what happens, and it kind of turns, slowly, slowly, slowly. It takes a lot longer for it to come back to target. But as it does, and when it comes back to our the target eventually, now it's going to rotate towards, and it might hit. Okay, but that's not bad. See how it rotated away, and then it rotated back, and it's trying to get to the target, but it's just not. It's moving so fast relative to its rotation rate that it just can't make it towards the target. That's the effect of the grid. The grid is a constraint, right? If we didn't have the grid, my friends, things would be a lot easier. Right? I can just have nodes and I can say, okay, go there and then avoid this way, and it would just do it, right? The grid is what you need to focus on, because that's giving us a container for us to, and the challenge, right? To make it work, snap to grid, all those kind of things that we're learning how to do, okay? The other thing we can change is whisker length. So if I reduce the whisker length itself right down, let's say I reduce the whisker length to something like, I don't know, much smaller, like 150. It's 150 units, so it's only looking forward, kind of a bunch of units. Now, what happens is, and let's just increase the turn rate back to, let's say 40 degrees or 45 degrees. So it can really turn quite significantly, right? Now, as it's moving towards the target, it's going to switch 45 degrees, right? 45 degrees is on the diagonal. So if it looks janky to you, it's because it's turning right to the diagonal. That's what it's doing right now. See, it's turning up to 45 degrees, right? That's what it's doing, and that's how we've programmed the avoidance behavior. The avoidance behavior is going to turn based on your rotation rate. Okay, so notice it does it. So the smaller the whiskers, kind of make it so that it approaches the target a little bit closer before it makes that change. Okay, and it avoids, and comes back. And it can make it with 45 degrees. Notice it passes through the target. Where it's funky is if I stop it, let's just move it over here, and I stop it over here, and then I press arrive. Now let's see if it can actually do arrive. And this is the funkiness. Remember, it's 150. 150 doesn't do arrive. It stops before it gets there. But now it's going to see a, oh, look at that. It made the arrive. Oh, but then it kicks itself out of arrive because once it's rotating, because it keeps rotating, because arrive's not fixed. I haven't fixed arrive yet. You're going to do that, or you should have done that already. Then it'll keep coming out of there and try and avoid the direction. This is the proper behavior that we've programmed, right? So tweaks. What could you do differently? Can anyone have some suggestions? Because people are going to ask these questions. Let me just put this up on DevOps so you have a copy of it. we'll say deployed obstacle avoidance version 1. That's what it would be. It's not really a great obstacle avoidance. It's okay, right? It does the job. But again, tell me if I was going to look at the obstacle avoidance algorithm. We've been talking about algorithms. How do we make this better? Is there something that you would do differently than this? Remember, rotation rate, the reason why we're using the avoidance direction just basically says which way do I turn, left or right, okay? Rotation rate is how much the angular velocity is. So if my angular velocity is high, then it's going to turn that amount. The entire amount, by the way, every single time, okay? Where it gets really janky is if you put it at 90, then it's going to be like, whoosh, flap, it'll flip right around, right? And it'll look weird, okay? The smaller the angles, it'll be more realistic, but because we're using a square grid, it'll look weird because what's going to happen is it's going to kind of slip to the left looking at the same direction, right? Because it can't quite turn enough to get there. It can't turn 45 degrees, right? So this is what's happening. It's returning the new vector, the new normalization, or the new normalized direction, whatever that is. And then it's being consumed and moved to target. Move to target, every frame, what it's doing is it's saying, okay, so, and this happens every single frame. It says, okay, well, I'm avoiding the obstacle, right? So things you could do is you could wait a few frames, a few steps, if you will, to avoid. Now, this is tricky. You might just try avoiding one step. How do I delay one step? Well, what I would do is I wouldn't turn off obstacle detected. I would create a counter of some kind, right? And the counter would literally count 1 or 2, and you could adjust that counter inside of like your user interface to see what that number would be. That counter is counting steps, like I'm moving across a game board, right? So if I want to step twice before I turn back, right? So a good example about that, if I go back to this, right? And if I take my ship, okay, I'm just going to modify it manually here. But if I take my ship and if I turn this way, away from my, from my target. So, sorry. Here's my target. I turn away from my target. Instead of me stepping one position like this, let's say, for example, I move here, right? And the next spot I move is here, right? Because let's say I have a rotation rate of 45 degrees, and then if the thing I'm trying to avoid that I'm hitting with my my whiskers is here, right? So I detected it and I'm moving away. I don't want to try and move back the next frame. Do you know what I'm saying? So because remember my whiskers are going in all these directions, right? So what I could do is I could continue stepping along that way for an extra frame, like up here. So I moved from here, I was facing this thing, I rotated, I moved here, and then I moved here, and now I'm going to start going back to the target. So that's another way you can make an improvement. You can wait a frame, wait a step in order for you to move back. Now this is okay, but what happens when I have multiple obstacles? That's a challenge. We haven't tried to do that. So that's one thing you could do. I'm just going to undo those changes. The other thing you can do is, we have whiskers, right? So one thing that we did with our start pawn is we have, a bunch of whiskers that we have, as an example, right? So like we have the whisker direction and all that kind of stuff. Let's just get out of here, configure whiskers. But we have a bunch of them, right? So, and the whiskers are on my ship, if you will, right? So when I configure each whisker, for each whisker, this does this. So these are all the local variables that we have, right? You guys drive me crazy. Let's configure each whisker. But we also have update whiskers. And in update whiskers, in our local variables, we have a bunch of whisker angles here. What if we don't need that many? I added 13 of them. But in the book, right, if we looked at our, the way we do things, wow, it's crazy. If we look at the way we do things, right, as an example, we only need 3. The one that's forward, this one, and a couple of whiskers at, let's say, 45 degrees. So what if we actually remove some of these? So I don't have all these whiskers anymore. I just delete them. Let's try it. So let's like get rid of these ones. We can always put them back, right? Shut up. Let's just see. Where's that? I think it's my Teams is still up. Here, let's just quit Teams. So we'll delete some of these. Here we go. Delete, delete, delete. And we'll delete the other ones. So we only have the whiskers that we have here. Okay, so just do this. We don't have even the 90-degree ones, just these ones, these 3. That's how, this is a classic example of whiskers, right? 245 degrees because we're in a square grid, and then the one that's forward. So this is something that we can do. Okay, and if we did this, and now we press play and we saw the whiskers, we're only going to see 3 whiskers. Okay, let's do that same example where I put this here, that there, and the obstacle in the middle. Are the number of whiskers helping or hurting is what I'm saying. So we can try that out. Let's slow it down. So we'll leave it at 45 degrees. We'll leave it at 150. We'll increase the step delay so that it's slow so we can see what happens. And we'll leave the whisker length the way it is. Let's see what happens. So seek. So it detected, it moves away, and it moves back. So why might this be better? Okay. Well, the thing is, just because there's more doesn't mean it's better, right? The more whiskers you put in, the more collision detection you're doing. And the more collision detection you're doing, you're actually, you could cause problems. It helps and it hurts. See how it that was kind of weird, what it just did there. It turned in the wrong direction. Okay? So it's not terrible. The other thing to do is each of these whiskers are the same length, right? So one other thing that you could do, let's go back and put those whiskers back in. Let's see if I can undo. I don't know if I can undo. Yeah, it does. Almost back. 10, 11, 12, 13. There we go. Let's see how much that is. There we go. There's all my 13 back. So I just did it. Undo a bunch of times. So if I do this, right, as an example, but what if we can generate whisker length as well, not just for all whiskers, but for certain whiskers. That's more configuration. Like for example, I can make the one that's in front of me really long, right? So what that'll do is I can detect a collision coming way ahead of time, like far, far away, right? Or whatever. But I can make my other 2 whiskers really short, so I can kind of skim by and make micro adjustments. I don't have to make everything the same length, and I can do that for all of my my whiskers, as an example. So I can make an adjustment. I can make the pattern of the whiskers, instead of looking like a like circular, I can make it so that it's more oval, right? Kind of the shape of my ship, right? So I can kind of go forward. I don't have that kind of control right here. All of them, from a whisker length perspective, are the exact same thing. Look, they're all the same length, right? How do I do that? Well, each whisker itself, right? Right now we have generate whiskers and they're just one thing. Whiskers could be a struct. So they have 2 things that they have instead of one thing. Instead of whiskers only being a direction, that's all they give you, a direction. Whiskers could have the direction and the length, right? And then when you have a direction and the length for each whisker, right? Then when you configure each whisker, it has, now it has all that because each whisker has a direction and length, right? But here inside of my array, my whisker angles, that's all they have, just angles, right? It doesn't have the length of the whisker, right? And so I can have a separate array, a parallel array, right, if I want to. And that parallel array could have you know, the same number of elements as the whiskers, and it'll give you the whisker length, you know, as an example. And that means if I wanted to do something like that, that when I run the code, right, that instead of having whisker length as one big bar, I would have a bunch of them, right? Each one I could adjust a little bit to create that shape that I wanted, right? Or maybe I would just take it away and I wouldn't give control over whisker length. I would create the shape manually, whatever it's going to look like, right? But the idea here is the same. So these are some thoughts to make it better for you. One thing else, even though we've made whiskers, I didn't say that you necessarily have to use this many, or that the whisker itself terminates in just like just a line trace. It could be a sphere trace that you're using instead. So an example of this would be right now, if I go back to my code. So in the grid character, when we're doing, we're doing a trace with the whisker in the start point, right? So every frame, what's happening is, you know, the whiskers are being, you know, kind of like detected, right? And we just made this change. But this is line trace by channel, right? But if I do a sphere trace, by channel, right? Here's my sphere trace by channel. And instead of doing a line trace by channel, at the end, wherever the end point is of the start and end is where my sphere starts and ends. I can make it so that the sphere itself is almost like a swept sphere. That's what I'm doing. So it gives me a much better volume, if you will. Instead of making each whisker a line, I can make each whisker a small sphere with the small radius. So let's suppose I made that radius something like, you know, small, like 5, right, as an example. And then I can use the same exact thing that I have here, but I'll swap it out. So I'll just take this and I'll swap it out with this, sphere trace by channel. So these are some things you can try. So let's say draw debug type is this. Everything else remains the same. I still do an out hit, and I still do all this stuff. So the exact same things that I did before. The only difference is that my sphere trace is going to be the same colors, right? And it's going to be the visibility channel. Let's see how this looks. It's going to look weird. So if I press play, and if I press debug, now you're going to get this. So each of these things is a more complex object, right? And so it's not just one line. And if I want to make, this is only like, I can make another thing in here, right? Instead of just whisker length, I could also make it so the whisker thickness is something that I can manage, right? So example of this would be that this thickness would be the radius, right? So let's make that radius, instead of 5, let's make it something like 20. Okay, and let's see what that looks like now. So if I did that, and if I press debug, you can see now that they're much bigger objects, right? So why would I do this, right? Because again, it kind of covers, area of coverage is bigger. And if area of a coverage is bigger, maybe I need less of them. Like, for example, maybe I can get off by only having the 3 whiskers with a, you know, kind of that shape, as opposed to, you know, a line. A line is okay, but it's very basic, and especially for 3D, right? Whereas what I'm actually seeing, you know, in 3 dimensions, let's just go to perspective. What I'm actually seeing in 3 dimensions is this, right? Which is a much more reliable way of connecting. Because what if I miss that line? This is a 3-dimensional sphere. It kind of goes up and down. It kind of makes it so that I can, you know, run away from what I'm doing, right? A little better. Now I don't need all of these if I'm going to do that exercise, right? So let's go back to top. And again, I can adjust that over and over again until I find the right number, whatever that right number is. Let's make it so it's 50. So to show you this, we're going to have a lot of overlap, but you're going to see that now. You know, take a look at the patterns that you're getting, right? You've got a complete sphere on top of everything. And again, I might be able to get away with just having those three, the middle one and the 45-degree angles, right? Okay, so what if I did something like this? This is like all encompassing, right? Like what happens then when it comes to my obstacle avoidance? Is it really janky? Like try it out, right? So let's do a seek. Yeah, it's kind of weird and janky, right? Now also take a look. It also detects my, my target. So it knows when I'm on target. It kind of does a lot of stuff for me because it detects everything. Before I wasn't detecting it because the target was below my line, so it didn't show that it was connecting. Now, because my spheres are quite large, right, it's detecting it. So it kind of shifts back. I think it needs an adjustment. Like I would adjust this thing a little bit, right? And again, there's opportunities for you to do that so that you can avoid, kind of detection. And I think also that you don't need so many whiskers. You can probably reduce that and still be efficient enough to avoid and have less janky movement, right, with all this stuff. So lots of little things that you can do to adjust. It really comes down to how you feel you want to make your AI maneuver, right? Remember, this is the first part, the most important part of any kind of AI is movement. How do I move that thing, right? And the more I control its movement, the more realistic it looks. Questions around this? So I'm giving you some leeway. Like there's a lot of ways to do this thing. You don't have to do the bare minimum that I'm giving you, right? What I'm giving you is just hey, this is a way of using like a line trace, the classic way of doing things, and from a 2D space perspective. We're not in 2D space, we're in 3D space, and we also want to make some adjustments to make it a little better, kind of thing. How do we do that? Well, here's some things you can do. So, thoughts. What are your thoughts before we go for the day? Just gonna make sure that everything's back to normal. No thoughts. What should be interesting to you as developers is the control that I'm trying to get you to have. Remember, what I'm giving you is something that is testable, right? You can't test so easily when you're using a nav mesh that's been made by somebody else, right? You can test more easily when it's your creation, when you have control, right? And what you can do step by step. That's what I'm trying to this part of what we're doing this semester is giving you the control you need to move things around properly. And the things that I'm showing you are transferable. You don't have to use it in Unreal Engine. It could be Unity, it could be your own engine, it could be whatever, right? And that's the idea. And also, you should have thoughts in your head about, how could I improve this thing? Or why are we doing this? Like, questions that you should look at. I had a student last year around the same time, and he's like, why do I need a grid at all? Like I don't need a grid. I can avoid it. I don't have to use all these things. You're right. You don't need a grid. But it's the challenge of subdividing your space in 3 dimensions. Right now, we're only moving in a 2-dimensional plane. Realistically, we're using a 3-dimensional map in 2 dimensions. But what if you had to climb or go down? Like, what if you had to avoid something that was in, like when you're flying? Like, we're having a spaceship here, and the spaceship is flying in one straight line. But that's only like 2-dimensional thinking, right? We want to be able to avoid climb and dive, right? We don't have that kind of game right now, but we could. We could do that because we can subdivide the world into not just a 2-dimensional grid, but a 3-dimensional grid, right? Grids give you a lot of control. All right, that's it for me, guys. Just a reminder, and again, I know it's okay. You don't have to have thoughts. No thoughts. But just a reminder about when everything is due. What I've done is I've moved, I know, right? I'm sorry, Logan. I've moved the due date for assignment 1B to be helpful, like I said, again, to this Sunday. So you have a couple of days to get everything done. Hopefully you've submitted some things already for assignment 1, assignment 2 for the other courses, right? As we approach Sunday. Sunday at midnight, it gives you a couple more days. Otherwise, it'd have been due tonight at midnight. And I know tomorrow also is Valentine's Day, so it might give you a chance to get things done. There's not a lot that you have to do to tweak it. I'd like you to try and adjust some stuff that I've given you, because for the most part, I've given you 95% of everything you need for AI. Okay. Any questions before we go? All right. Well, if there's no questions, guys, again, good luck. Remember also that your tests for all 3 courses are coming out on Sunday or Monday, right? Sunday or Monday, I'm going to release all the stuff. I will release a video with those things as well, and you'll be able to have the remainder of the week, whatever's left over, to get it done. Okay, guys, thank you so much, and I'll see you in the videos. I also will be there Wednesday, Thursday, and Friday, just like normal, but just remote, so I can be there if you have any questions about the exam. Okay, guys, take care and enjoy the weekend.